All right, guys, for 4.4, we have scatter plots and lines of regression, which we've talked about a little bit in class, I believe. So let's just cruise through this. This is going to be kind of a fast lesson. Feel free to pause it if you need to, ask questions of me maybe in class at some point, but let's just jump through this. So we have 4.4 scatter plots, lines of regression. First of all, let's get some terms. So bivariate data, that word bi, that prefix bi should look familiar. A bicycle has two wheels, right? So this is going to be data with two variables. These variables are related and are used to make a comparison. Okay, so we often call this the dependent and independent variable. So get that in your notes. We're only looking at two variables with this assignment. So what is a scatter plot? So bivariate data, okay, again, that's data has two things with some relationship, is graphed as an ordered pair. Okay, so graphed as ordered pairs on a coordinate plane called a scatter plot. All right, so that's what a scatter plot is. It's just all the random data that you get with the relationship between two things. So here's a bunch of examples of them. The first picture you see here, the red line that you see there is called a line of fit through the data. So it's a line that's as close as can be to all the data. And you can see there that that line has a positive slope. So we say this has a positive correlation. And then the middle one there, we see that that is a negative slope. So there's a negative correlation. And then finally, you can't really draw a line through the last one there. I mean, I guess you could draw a number of different lines, but there's no real strong correlation anywhere. So we say that that has no correlation. Okay, as I mentioned, there's a line of fit through that data. That is the red line that is there. It's a line that closely approximates the set of data. So that's the word there, the approximates. And so now let's do some examples. So a prediction equation. Okay, here's the big idea, is if you get a trend happening, okay, and you have all this data here, I'll just draw like a positive correlation. And then I draw a line through the data. Oop, don't do that. A line through the data, as best I can, straight line, like that straight line. And basically, that line represents the trajectory of the data, so that I can make a prediction of things that happen that are not pictured. So like maybe something that happens down here on the X that's not on the graph, I can say, well, if the trend continues, I can make a prediction about what would happen up here, right? Using that line. So it's called the prediction equation. And this is really no different than when we found an equation between any 2 points. Okay, it is a little bit different, but the technology is going to help us with that. So first of all, if we're not using tech, what we're going to do is we're going to draw a scatter plot out. So they're going to give you a bunch of data and a chart. You're going to put the data onto a graph, and then you're going to approximate a line of fit. What you'll then do is choose 2 points, any 2 points that are close to the line. So maybe I chose this one and this one, right? And you're just going to use those 2 points to come up with an equation for the line through those 2 points. Okay, so if you know 2 points, you can find the slope. If you know the slope and a point, you can find the equation of the line. All right, using your point slope form. All right, so that's what we're going to do. That's our steps. Let's do it. So here's an example. I don't think this is in your actual notes there. I just wanted you to watch this one. But maybe for the sake of time, maybe we'll do the one that is in your notes, which is, I think, this guy. Okay, so we have a bunch of data here. We have X values, they give us Y values, and then we have a chart. This chart is nice because it's going by the actual year. Sometimes they'll identify these years as like years since something. So it's important to look here to see how the graph is given and to read your problem carefully. But let's just get into it. So if I'm going to graph these points, at 2004, the Y value that corresponds, and I'm sorry, but this whole thing is supposed to be right up here next to this. Okay, so the first one goes to the first one, second to the second, etc. So 2004 is 172.1, which is going to be somewhere in here. 2005 is going to be 180.5, which is somewhere in there. Okay, 2006 will be 189.5. So 2006 will be close to 190. And then we have 2007, which would be 186.5. Okay, so it came back down here, somewhere in there. And then 2008 would be 184.7 or close to 185. So that would be right in there. And then 2009 is going to be 178.5. So 2009, 178. Whoa, this is interesting data, right? So we have that. And then 2010 is going to be 184 essentially. So that's right in here. 2011 is 190. So 2011 is 190-ish, somewhere in there. And then we have 2012 being 195, which is up here, somewhere in there. Okay, so I'd be tempted here to say there's not really a strong trend, but if I had to draw a line of fit through this data, if that's what they're asking me to do, I think the 2 points that I would choose would maybe be these 2 points right here. I think those 2 points, this guy and this guy, which correspond to the years 2004 and 2008, those 2 points, I think would work well. So I'm going to use those 2 points to create an equation. Okay, so to create an equation there, let's just get the actual coordinate. So 2004, I was at 172.1. And 2008, I was at, I'm going to have to count 1, 2, 3, 4, 5, 1, 2, 3, 4. I was at 184.77. Hopefully I counted right there. Okay, so I need to create an equation, right? So this is just 2 points. You know what? For the sake of this, and depending on how exact they want you to do this in your homework, I'll let you do something like this. I'm just going to estimate this and round it to the nearest whole number just to make life easy. So my change in y would be 185 minus 172. My change in x would be 2008 minus 2004. Okay, so my slope there is going to be, that looks like 7 over 4, which you could just leave as 7/4 actually, that's fine. Okay, so I have the equation y equals 7/4 x plus b. I can now take either point and plug it in and solve for b, or you could use point slope form, right? So either way works. I'll do it this way since a lot of you like to do it this way. So I'll use this guy. Okay, so the y value is 172. Got to use the rounded one. And then the x value there is 2004. And then plus b. Okay, so let's do some quick math. If you take 7 times 2004, I'll do this on my calculator here, I get 14,028, and if I divide that by 4, this whole thing simplifies to 3507 plus b. Okay, so then if I subtract this from both sides, ooh, we're going to have a big number here, aren't we? 172 minus 3507 gives me negative 3335. Now, if I were to put that point on here, clearly this line does not intercept the y at negative 3335. Okay, so what is that telling me? It's telling me that I did something incorrect. All right, so if I go back here, I'm guessing this year piece is the party foul. Okay, so instead of saying 2004 when I plug that back in, maybe what we'll define it as years since 2000. Okay, so if I did years since 2000, then that actually becomes a 4. Okay, so let's try that. If we did a 4 there instead, hopefully you guys caught that. I'm going to get rid of this. Sorry if you had to erase. So if I did 4 here instead of 2004, that would make a lot more sense. It's probably being identified as years since 2000. Okay, so then I would do 7 times 4 is 28. 28 divided by 4 is 7. So this is simplified to 7 plus b. And this seems to make a lot more sense. So b then would be equal to 172 minus 7. So you subtract 7 from both sides and you get 165. That seems a lot more accurate with our picture there. Okay, so let's go with that. That might happen to you. The years are always the party foul. Just make sure you read the question carefully. This one didn't have the directions laid out, so that's why I did it that way. So sorry about that. But look, our final answer here then would be y equals 7/4 x plus 165. Just plug that guy back in. Okay, so I have y equals 7/4 x plus 165. The correlation here is positive. And often what they'll have you do is make a prediction. So they might say, what happens in the year 2022? Well, you'd plug in the 22 for x into this equation, and then you would know where you were at. Okay? So that's that one. The final piece here is that you can do all of this with technology, and this is what you're going to do with your projects. And so I'm going to try to explain it here on this video, but you know, we might have to do some more in class. So regression lines with tech, okay? What we're going to do is I'm going to show you how to do this. I'm on the iPad Desmos app, but you could go to desmos.com, and it's very similar. Okay, so I'm first going to just show you how to get to regressions within Desmos. Okay, so I'm going to hop out of this. I'm going to hop into Desmos. Okay, and in Desmos, yours might look a little different online, but you should have in the upper left these 3 bars up here, right where it says next to where it says Untitled Graph. I'm going to click on that, and there should be a menu that drops down. You're going to scroll down to where it says Statistics Linear Regression. Statistics Linear Regression. You're going to click on that. Okay, and what they've done here is they've populated a sample. So this is a sample, an example. We don't want any of this data. This is not our data. So I'm just going to delete. So I'm deleting the table. Just be careful, you don't want to delete the whole table, you just want to delete the data that's in there, so use your backspace. Okay, so I'm deleting all of this. And now what I can do is, instead of plotting this all by hand, I can just put in the X's and the Y's and let Desmos do it for me. Okay, so I'm not going to go back and forth and do all of this with you here, but just know that on this one, we can use, so in this one we have years and sales. Let's make sure we read this correctly. It says the table at the right shows the percent of sales that were made in music stores in the United States for the period 1999 to 2008. Use a graphing calculator to make a scatter plot of the data. Find and graph a line of regression. Then use the function to predict the sales made in a music store in 2018. So for this one, what I might do is actually use the years here. Okay, so you guys can play with this. Let's just use the actual years. So what you would do is plug in this information. Okay, and you guys have it there in your notes. You're going to plug it in on Desmos. And when you do that, it's going to give you a bunch of information. So I'm going to show you that information here. Okay, so I'm going to go back to the example and show you what it's going to spit out. Okay, so again, if you missed it the first time, I'm going to go to the menu. I'm hoping that it will reset it here for me. I'm going to go to Statistics Linear Regression, if I can find it. They might make me go to another one first. Don't worry about that. Statistics Linear Regression. Okay, and notice for the data that they just randomly put in here, which again you're going to delete. If you scroll down, this box down here with the little orange thing on the left tells me a lot of information that's very important. Okay, first of all, you can see down there that it gives you M. M is equal to 1.32989. That's the exact slope of the orange line on the picture. So it calculates it for you. And then the B value, negative 0.296258, that is going to be the y-intercept for this data. Okay, so it gives you essentially the equation for the line. There's no calculations like you had to do in the other example. It just spits it out for you. Okay, so I want you to do a couple by hand if it tells you to choose your points in your homework. If it tells you to use technology, I want you to hop on Desmos and try to fill this in. You can work with your partners to make sure that you guys are getting it. And then later we'll talk about this R value. The R value talks about how strong of a predictor it is. It's called the correlation coefficient. And in this case, it is very strong because it is 0.9, which is very close to 1. But that's all in another lesson. All right, so that's it for this time, you guys. I'm going to hop back into this guy. This talks about if you have a TI, the steps that you would do on your TI, which most of you do not in Algebra 1. But if you wanted these directions, I can work with you on that. The homework is pretty short, but it's very involved. Okay, so it's page 250. I hope that page number is accurate with the new textbook. You're going to do 1 through 11 odds. And I hope you have a homework sheet for that. If not, some lined paper will be okay. And just do your best in labeling that. All right, you guys, take care. See you next time.